Hello, I'm Andrea, and I'm Higgs Hunter. I'm looking for the Higgs boson decay into two double bosons. The double bosons themselves are unstable particles. They can decay into hadrons or leptons. I concentrated my quest looking for electrons, muons, and neutrinos in the final state. When a double boson decays, it can decay either into electrons and a neutrino or a muon and a neutrino. Electrons and muons are nicely reconstructed. On the other hand, the neutrinos are invisible. However, by looking at the electrons and muons going in one direction in our detector, the neutrinos are going to recoil against them, carrying out part of the momentum. By measuring the imbalance in the momentum of this system, we can measure the momentum of the neutrino. Although this is a quite challenging final state, it gives us an important probe in order to measure how strongly the Higgs interacts with double bosons. In addition, by measuring the correlation between the final state objects, we can measure the properties of the Higgs boson itself. In the discovery era, we did not know what was the mass of the Higgs. However, exploiting the big decay fraction of the Higgs boson into two doubles, we could scan a broad mass range and see where the Higgs boson was hiding. And this is what we have done. After we discovered the Higgs boson, we started deeply investigate the Higgs boson into two double final states. We measure the Higgs boson properties, such as spin and parity, and at the end we also perform a precise measurement of the transverse momentum distribution of the Higgs boson itself. With LHC run2 data, we could discover the Higgs boson just looking at the double-double decay mechanism. There are a lot of new adventures ahead of us. With more data, we can study the Higgs boson in different and more rare production mechanisms, and who knows, maybe discover some discrepancy with respect to what our model, the so-called standard model, predicts.